Balancing chemical reactions. It's a very important technique to master in order to do more problem solving in chemistry. But it has a reason why there is a reason why we balance chemical equations. We balance them by first of all writing whole number coefficients before each reactor or product. But the purpose of chemical equation balancing is to show the law of conservation of mass. According to the law of conservation of mass, matter cannot be created or destroyed. Matter cannot be either gained or lost in the process of a chemical reaction. Whatever we start with in our reactants must be preserved in the products. Sure, the identity of the products is different than the identity of the reactants, but when you count the individual number of atoms of each kind in the reactants, you must have the same number of atoms within the products as well in this of the same kind. So as I said previously, we balance chemical equations by writing whole number coefficients. What's a coefficient? When I say 2x plus 3x equals 5x, the number 2, the number 3 and the number 5 are coefficients, and you know that from your pre-algebra class. Similarly, here in this chemical equation you have 2 HGO solid, 2 Hg liquid and 1 O2. Whenever you don't see a number, that means there is a 1, not a 0. Please keep that in mind, 1. So this 2 and a 1 here, as is understood, are all called coefficients. The coefficients tell you how many of that substance are in the reaction. So I have 2 of HGO, 2 of Hg and 1 of O2. By the way, 2 of what? 2 grams of HGO or 2 atoms of HGO or what? First of all, what is HGO? Is HGO an atom? No, it's a compound. So 2 compounds, but what exactly? Are we talking about 2 molecules now? Since HGO is an ionic compound, we call it 2 formula units. So I can read this as 2 formula units of HGO decomposing to produce 2 atoms of Hg and 1 molecule of O2. Yep. What you cannot do is read this as grams. You cannot read this as 2 grams of HGO reacting to produce 2 grams of Hg and 1 gram of O2. First of all, that doesn't make sense according to the law of conservation of mass, because if you start with 2 grams, you should have 2 grams. But if this is 2 grams and this is 1 gram, that's 3 grams. So that's not possible. So it's read in the total number of atoms or molecules or formula units. The other way of reading it, and the preferred way, is to read it in moles. You can say this as 2 moles of HGO decomposes to produce 2 moles of Hg and 1 mole of O2. So those are the coefficients, and this is a balanced equation. Why? Because you have 2 Hg's on each side, you have 2 O's here, and O2 is 2 atoms of O. When you are trying to balance the equation, you want to break everything down into individual atoms. Whether they are compounds or molecules, count the total number of atoms. So here you have O2, a molecule, but there are 2 atoms of O combining to form that molecule. Here you have HGO, 2 HGO, 2 formula units, but 2 formula units put together, you have 2 atoms of O. So that means 2 atoms of O here and 2 atoms of O here. 2 atoms of Hg here, 2 atoms of Hg here. That's how you balance the equation. So here is an example. Hydrogen gas and oxygen gas combine to produce water. This is a very well known equation. But is the equation showing the law of conservation of mass as written? No, because you have 2 atoms of hydrogen on each side. That's balanced. But you have 2 atoms of oxygen on the left, but only 1 atom of oxygen on the right. What happened to the other atom of oxygen? Was it lost? If it's lost, then we are not showing the law of conservation of mass. And if it's a law, it should be applicable under all circumstances. So how do we balance this? Can I put a balanced equation by putting a 2 here? No. That would change the formula of the compound. H2O2 is actually a different compound. It's called hydrogen peroxide. But that's not what forms here. We say it specifically forms water. I can only balance an equation by putting coefficients as necessary. Currently, where you don't see any coefficient, there are still 1s. 1 H2, 1 O2 and 1 H2O. I will change the coefficients to have it balanced. First, what you want to do is make a small table or write down the number of atoms of each kind on the reactant side and on the product side. So hydrogen, you have 2 on reactant side and 2 on the product side. Oxygen, you have 2 on the reactant side but only 1 on the product side. Now when it's balanced, the numbers you see on the left will be the same as the numbers you see on the right. Okay. Determine which elements are not balanced. Do not have the same number on, well, when they are not balanced, they will not have the same number on both sides. So it's the oxygen which is not balanced here. We have 2 on the left while 1 on the right. Then balance one element at a time by changing the coefficients. Okay. In order to make this 2 here, which is on the product side, oxygen is found only here. Since I can only change the number right here, if I put a 2 here, I can then go and change my table and put a 2 there. But every time you make that change, something else can also change, and you need to check every time whether something else change or not. Sometimes nothing will change, and when nothing changes, that's the best outcome you want, but other times something will change. And when I balance my oxygen by putting a 2 here, what happens to my hydrogens? 2H2O, how many total atoms of hydrogen? That's 2 here times 2, making it 4 hydrogens. So while I balanced my oxygen, my hydrogen got unbalanced. I now had, well, here, when I put a 2 here, that balanced the oxygen, but hydrogen is not balanced. I have 4 hydrogens here, but only 2 here on the product side. So what will I do now on the reactant side? Sorry. So what will I do now? I'll go back to that table and then I will change this to a 4. But in order to make this 4, I would have to put what here? 2. 2 times 2 will make it 4. And when I do that, by putting a 2 there, that's when everything is balanced, and in that last step nothing else changes except hydrogen. So I have 4 hydrogens here, 4 hydrogens here, 2 oxygens here and 2 oxygens here. Everything is balanced and we just obeyed the law of conservation of mass, okay, which is what we will always have to obey. And so that's how we balance the equation. Okay. Here is another way of seeing how a balanced equation is written. Nitrogen gas reacts with hydrogen gas to produce ammonia. That's a known fact, a very important reaction in the creation of fertilizers. But is this equation balanced? See how many blue balls you have here, 2, but only 1 here. How many pink ones you have here, 2, but 3 here. So it's not balanced. You need the same number of balls of each color. So what do? You have to balance the equation. Okay. And when you balance it out, notice what happens. You have 2 blue nitrogen balls and you have 2 of them here as well. And here you have 6 hydrogen balls, pink ones, and here if you count 1, 2, 3, 4, 5, 6. And so all the atoms are balanced, and N2, 1 mole of N2 reacts with 3 moles of H2 to produce 2 moles of NH3, or 1 diatomic molecule N2 reacts with 3 diatomic molecule H2 to produce 2 molecules of NH3. You can read it as either of the 2 ways. Here are a bunch of different reactions that you should try to balance. I suggest you make a table keeping track of each of the individual atoms. Now when you have something like polyatomic anions like NO3, they stick together. Notice how NO3 is here and NO3 is here. You may put a table where you keep the whole NO3 on the left. So for example, for the second one, the identities of the elements that you want to balance would also include a polyatomic anion NO3. So you are balancing Ag, Fe, Cl and the whole NO3 by itself without breaking it up into nitrogen and oxygen. Here you are balancing carbons, hydrogens and oxygens. Here nitrogens and hydrogens. Again here carbon, hydrogen and oxygen.